Hi everyone. So now we are proceed to chapter 4.4 about intermolecular forces. Before we go further, I would like to explain what's the difference between intermolecular forces and the intramolecular forces that you have learned before. We talk about the covalent bond. So what is it referring to? So for example, HCl. Due to the difference of electron negativity, Cl will carry the partially negative charge and hydrogen will carry the partially positive charge. This one is within the molecule. This is what we call the covalent bond. It's in the molecule. So it also considered as molecular forces. So it's within the molecule. When we refer to intermolecular forces, meaning that the forces between molecules. For example, so another molecule of HCl, so because of the opposite charge, they will attract to each other. So it must be very close to each other. It only exists the intermolecular forces. So in this case, this is called intermolecular forces. It happens between molecules. Example, at least have two molecules. It's between molecules. Studying intermolecular forces can help us to have better understanding or read the reading of boiling point and melting point. If it has higher boiling point or melting point, it's referring the solutions have stronger intermolecular forces. So if you have stronger intermolecular forces, it needs more energy to overcome the attraction forces. So how are we going to relate to this matter? For example, boiling process. Recap what is boiling process. So it's from the liquid to become gas. Initially, if it's liquid in normal conditions, it moves in zigzag directions. When we provide energy, it will cause the average kinetic energy increase. So all the atom molecule will move faster. At the same time, it can overcome the attraction forces between the molecules and able to escape to become a gas molecules. So same go to the melting process, which will give us the melting point reading. Is from solid to become liquid. So in this process, energy is needed. So when you provide energy, you're able to melt the solid to become liquid phase. The attraction forces between the molecule is referring to the intermolecular forces. Now we will going to specify the intermolecular forces. So the type of intermolecular forces, it depends on the compound. For example, if it is ionic compound, so the intermolecular forces for the ionic compound we call ionic bond. If it is metal, it will have metallic bond. If the compound is covalent compound, how about its intermolecular forces? If we divide into two types, the first one we call van der Wall forces. Okay. The second one we call hydrogen bonding. Under the van der Waals forces, we have another two, which we call dipole interactions, or normally we call it as permanent dipole. Okay, all these terms you need to be very clear, okay, not to get confused, then you only understand this topic. The second one is under the van der Waals forces, we call London forces, or it's called dispersion forces. Class, so now I give you an overview of this chapter 4.4. So the 4.4 is cover this covalent bond, the intermolecular forces of the covalent bond, which we study in detail for the van der Waals forces and hydrogen bonding. So each of it, you need to know what are the factors. Okay, the factor will affect the strength. Okay, for sure. Must have a reason that caused the intermolecular forces become stronger. If it is stronger, why? What is the impact toward the boiling point and melting point? So same go to this one. How is the hydrogen bonding can be formed? What are the criteria or requirement in order to for a compound that able to exhibit the hydrogen bonding? And metallic bond is fall under 4.5. Yes. Now I am going to explain what's the difference between the dipole-dipole interactions and the London forces. So first, I will explain dipole-dipole interactions, or we also call it as a permanent dipole. So actually, I prefer use this term permanent dipole because in a polar molecules, okay, in a polar molecules, okay, the molecules have a permanent dipole moment. Okay, for example, HCl, these molecules. Okay? As we know that chlorine is more electronegative, so it will carry the partially positive and hydrogen atom will carry the partially positive. No matter how the atom move, okay, no matter how the molecules move, the charge, the partially charged, the electronegativity will still the same because they are polar molecules. So when these two come to very near to each other, so it will have the intermolecular forces, which we specify it, call it as dipole-dipole interactions. Even in the absence of permanent dipole, molecules will still attract one another. This is shown by the observation that non-polar molecules such as nitrogens, oxygens, and so on. Meaning to say that for the non-polar molecules, the temporary dipole can be induced. This is because the temporary dipole is caused by the temporary fluctuations in the electron density in a molecule or in an atom. For example, an atom has positively charged protons in its nucleus and its negatively charged electrons surrounding the nucleus. On average, the negative charge of the electron in an atom is spread evenly around the nucleus. However, at any given instant, the electron distributions in the atom may be asymmetrical. Okay, may not be even. Okay, for example, this part, okay, the electron density is quite low, whereas this one is higher. So this is why it will take out a partially negative this side and the partially positive at this part. So the atom is keep moving. So meaning that this is not a temporarily dipole as what I explained the previous one, permanent dipole. So it will keep on moving. It depends on the fluctuations of the motions of electrons. So, and this will give them a temporary dipole moment. So all this is temporarily. London dispersion forces are significantly only when molecules are very close to each other. This is because electrons repel one another. The motions of electron in one atom influence the motions of electron in its near neighbors. Thus, the temporary dipole of one atom can induce a similar dipole of an adjacent carbon. Adjacent carbons meaning that the another molecule, another atoms, causing the atom to be attracted to each other. Now let us continue for hydrogen bonding. Under this subtopic, you have to cover all aspects. I will use this example to explain hydrogen bonding. So the first criteria to form the hydrogen bonding, within the molecule itself, the hydrogen atom must directly attach to the high electronegative atom. So this is the first criteria. A lot of students get confused. They are thinking that this is the hydrogen bonding, and which is the wrong. Okay, which is wrong. So this one actually just a normal covalent bond that you have learned before. Okay, so this is not the hydrogen bonding. So the next criteria is the hydrogen bond only can be formed with the next hydrogen molecule, which means this one is attached to the oxygen's a high electronegative atom. So, and this is called hydrogen bonding, the intermolecular forces. Okay, within the molecule, we call covalent bond. It's not the intermolecular forces. So hydrogen bonding, it's only happened when within the molecule itself, the hydrogen atom is directly attached to a high electronegative atom. Then the same hydrogen atom also attached, okay, to the another hydrogen oxygen atom, which is high electronegative, okay, which means the another water molecule. So in between the two molecules, then this is called the intermolecular forces, and we specify it and we call it as hydrogen bonding. So here are the example of high electronegative atom, fluorine, oxygen, and nitrogen, and arranged in descending order. Next, I will going to explain the solubility part. Okay, I give you an idea. We compare between this organic compound. Actually, this is alcohol. We call methanol, and this one is methane. So it's an organic compound. So to determine whether the solubility of a compound in water, meaning to say whether the compound can form hydrogen bond with water or not. If it's able to form the hydrogen bond with water, meaning that it's soluble in water. If the compound unable to form hydrogen bonding with water molecules, meaning that it's unable to dissolve in water. So the first example I want to like to explain here is we compare the methanol in water, whether the methanol is able to dissolve in water or not. So first we consider this hydrogen atom, whether it's direct attached to the high electronegative atom or not. Yes, with oxygen. Whereas this one, the hydrogens, this one is not the effective hydrogens because the hydrogen is attached with carbon. Is direct attached to the carbon. So these hydrogens able to form hydrogen bonding with water molecules. So in this example, methanol is able to dissolve in water. Next, we look at methane. Okay, methane, this hydrogen atom is directly attached to carbon. It's not a high electronegative atom. So the example of high electronegative atom, fluorine, oxygen, and nitrogen. So meaning that this is not an effective hydrogen which will not involve in hydrogen bonding. So when there is no hydrogen bonding can be formed with water molecule, meaning that this methane not dissolved in water. Sorry, not saying dissolve, which means methane is not soluble in water. As a conclusion, I attach this layout for your reference. Again, where should we start from this layout? This is the icon. I'm sure that you have get used of this kind of like layout. So first question to ask, what types of molecule? If it is metal, so it has metallic bonding. So not to forget, study this one in chapter 4.5. Please study the electron C model and study the factor that affecting the strength of metallic bond. If there is positive ions or negative ion involved, meaning that it is ionic compound. So if ionic compound, there is a ionic bonding. If it is covalent compound, so the next question to be asked, are hydrogen atoms bonded to F, O or N atom? If yes, then meaning that there is a hydrogen bonding. If no, meaning that we will go to this side, van der Waals forces. So if under van der Waals forces, you have to identify whether it is only London forces or dipole forces and London forces at the same time exist. So the next question to be asked is, are molecules polar or non-polar molecules? And this one you have done it, how to determine the polarity of a molecules. So let's say if it is non-polar molecules, so meaning that it is only have London forces. If it is polar molecules, then it has both dipole forces and London forces. So that's all for today. So thank you for watching. Happy revision.